possible. Just like with decimals, the book kind of ties up the stuff that you can do with fractions with this little statement here. Fractions. Here's your handy dandy little helpful chart here. If they talk about a fractions chart, this is kind of what they're going for. I don't know if we have to draw it out exactly like they did, but when you work with fractions, you have either you are multiplying, or either you're adding and subtracting them, or you are multiplying them / dividing them. What is the difference between when you do those two things, or those four things, whatever it is? When you add and subtract fractions, first of all, you should write up and down. And then you need to find common denominators, correct? Adding and subtracting fractions are much more difficult than multiplying and dividing. Multiplying and dividing, you write them across, correct? And then you multiply across. Well, if it's dividing, oh wait, sorry. You write across, and you have to remember that if it's mixed, you need to make it improper. You don't have to make these improper. With adding and subtracting, it's actually easier if you don't. You just get to work with these numbers. And then you either multiply across, or if it's dividing, what do you do if you divide fractions? Chase?
Then probably switch the second one.
Flip and multiply the second one. And then guess what the last step is in both of these? In both of these, you need to do what? Anybody? In math, so if we call it
Reduce.
Yeah, reduce, actually we call it simplify, which encompasses both reducing and making a mixed number, an improper fraction, a mixed number. So when they ask you about your little fraction / whatever chart, this is really what they're asking you for. I don't think you necessarily need to recopy it all, but in your mind, hopefully you're getting that down. You know, adding and subtraction, you write up and down, make common denominators, multiplying and dividing. Do we need to do an example? Sure, why not? Now, if it's 3/5 plus 7/8 as opposed to 3/5 times 7/8, this one here, you write it up and down, 3/5, 7/8. What is my common denominator of 5 and 8? Anybody have any thoughts on that? Grace! Smallest number that 5 and 8 go into. 8 doesn't go into 20. 8 doesn't go into 25.
No, 24.
And 5 doesn't go into 24.
40.
40! Yeah, that wrong. 40. This one doesn't have one. You make them both 40s, multiply this by 5, top times 5, you get 35. This times 8, that times 8, you get 24. Add them together, you get, wow, 59 40ths. Which you can't leave. It makes a mixed number of what? Anybody 59 40s? How many times does 40 go into 59? With what left over? 19.
Yeah.
Now, how much easier is this? What do I do with 3/5 and 7/8? You just multiply across. 3 times 7 is 21. 5 times 8 is 40. Can I reduce 21 over 40? No. That is it. The other thing in this lesson is multiplying 3 or more fractions. Let me give you an example. And then I shall set you free. And if you're free, you shall be free indeed. Let's say you've got 2/3 times 1 3/5 times 3/4. Oh, did I forget? We might have forgot to make the proper fractions there too. Oh, no, we did. So the first thing I have to do here is
Make 1 3/5 improper.
2/3 is going to stay. 1 3/5 is 1 times 5 plus 3, 8/5 times 3/4. Now, guess what the wise student would do here, Zach?
Right. Cross. Cancel.
Which means basically it is reducing before you multiply, because you don't want to multiply all those numbers and have really big numbers to reduce. You look to see what numbers can you reduce beforehand. For example, the easiest one here is you got 2 identical 3s, so you divide them both by 3, they go away. What else can cross cancel? Connor?
2 to 1 and 4 to 2.
2 goes into 2 one time, 4 goes into 2 times. Still more? What else? Layton?
2 goes into 8.
2 goes into 2 once, into 8 4 times. And then once you've done as much of that as possible, then you can multiply 1 times 4 times 1, which is 4, and 1 times 5 times 1, which is 5. If you cross cancel all you can right away, you should never have to reduce in the end. Everybody happy? How happy?